Let's take a moment and look at solving some compound inequality examples. So the first example I want to look at is actually an example of an AND. It's an interval. It's saying that the quantity of 2x minus 5 has to be in between 17 and negative 7. So the first step I like to do with these is write them out as two separate inequalities. So the first inequality would be something like negative 7 is less than 2x minus 5. And the second inequality would actually be 2x minus 5 is less than or equal to 17. And that gets at both components of my AND. So here's the first one. Negative 7 is less than 2x minus 5. And, don't forget this is an AND, 2x minus 5 is also less than or equal to 17. What I do next is I solve these separately of each other. So I'm just going to take this one right here and solve it on down. I'm going to start by adding 5 to both sides. You get negative 2 is less than 2x. I'm going to divide by 2. And I get negative 1 is less than x. And I'm going to come over here and solve this one. Add 5, add 5, 2x is less than or equal to 17. I'm sorry, should be able to do my addition properly, 22. Divide both sides by 2, x is less than or equal to 11. And don't forget this AND travels all the way down too. So really, I can read this as negative 1 is less than x, and x is less than or equal to 11. Written as a compound inequality, so if I want to write it like this again, I would simply write that negative 1 is less than x is less than or equal to 11. Or simply that 11 is in between 11 and negative 1. If I wanted to graph it on a number line, just real quick sketch here. Let's say 11's out here. Let's say negative 1's here. I want the interval between 11, including 11, and negative 1. So between 11 and including it, and negative 1, there's that interval. Now, the second kind of compound inequality is something like this. X plus 6 is greater than or equal to 7, or, that's our second kind of compound inequality, or x minus 6 is less than negative 10. And since this is an or, I'm just going to solve them independently of each other, much like I did the AND. Subtract 6, subtract 6, x is greater than or equal to 1, or add 6, x is less than negative 4. And since there's no number that exists that's bigger than 1 and smaller than negative 4, my graph would look something like this. There's my 1. Quick sketch for my negative 4. All the numbers that are bigger than or equal to 1 are this direction. And all my numbers that are smaller than, strictly smaller than negative 4 are this direction. So there's two nice examples of solving compound inequalities. One with an and one with an or.